Okay, so we create a selection by attribute in the dispatch date. So we're going to do is that we're going to do a select by attribute again, and then we will have a probably a new selection, but our add clause will be the dispatch date is on or after December no, let's just do one. Dispatch date is on or after whoa, that's cool. 12 a.m. and we're going to click add and add another clause, and it will be the linking expression will be or and end. End. All right, dispatch date, dispatch time. No, it's still date. Before on or before, and then the time will be January 31st, 2004, and then add a clause. So now let's double check. Create a selection by attribute in which dispatch date is on or after January 1st, 2014, and dispatch date is on or before January 31st, 2004, and then we're going to run the tool and just click run, and on the right hand side corner we see that selected feature is 640 robbery incidents during the month of January are selected on the map, and similarly we will create a layer from this selection, and we're going to export. Right click on it, and then going to data, and then export feature robbery, and the layer's name we're going to do robbery January, and we're going to click run, and then we're going to clear the selection and click the robbery layer, and then clear selection and uncheck. So now then we will create a kernel density for the robbery in January. So create a kernel density. A kernel density creates the density of features in an area around those features, and is one of the most common techniques in crime mapping. Cool. And in the analysis tab, and we're going to find kernel density. It's right here. And then we will click this and kernel density. So in the geoprocessing pane, we're going to set the following kernel density parameters. For input point feature, we're going to select robbery January, and then population field we're going to do is none. All right, and then output raster, we're going to change it into not kernel ID. We will do robbery underscore January and density. And if necessary, we're going to change the units to square miles. Right now, it's already square miles. And density for the output cell value and method is planar. The planar method is used because the map coordinate is WGS 84 web locator. Auxiliary sphere in the robbery data layer is stored in a geodatic coordinate system. And then we're going to run the tool. The kernel density is calculated and added to the map. The density is automatically classified with 10 classes and style using a random color ramp. So hopefully we will have everything perfect. Wow, it's really nice. Cool. Then 10. We did that. And we're going to select the wobbly density layer and go to the symbology layer pane, and in the class break section we're going to click the symbol of the first class at the top of the table and assign it no color. So no data and color scheme is fine, equal interval classify, and the first one we're going to do no color. The first class at the top of the, and then we have a no color. And on the appearance tab we're going to do is 40% transparency and at least dense class of the kernel density. Now it's a lot better. I don't need to select anything. At least dense cluster of the kernel density now has no color, and the remaining classes at 40% transparency, so allows you to see the base map. Okay, and next we're going to use more analysis tools on the wobbly layer to help visualize more of the hotspot. We're going to try to create a kernel density for other months to compare how each month differs, and try to creating a kernel density for other categories of crime. Do some areas have a more incidence of certain crimes than others? It is important to note when comparing density surfaces that the classification are the same. And using different classification causes different results. So here we did is equal interval. We could do other and see what's going on, but right now we already know how to do it. But anyway, let me save it real quick, and back in here we're going to perform a hotspot analysis. So we created a kernel density to briefly see where areas of high density may occur, and we will expand on how to build out an analysis by using other types of analysis tools. So here we're going to run an optimized hotspot analysis tool to find statistically significant hotspots and cold spots of wobbly. And we will also create a space-time cube, a data pattern mining tool, to look for trends over time. Well, that's really cool. Space-time cube and a data pattern mining tool. So we're going to run the optimize hotspot analysis tool to create a hotspot map, and we're going to run the create space-time cube tool to mine for data patterns and visualize the space-time cube in 3D, and we run the emerging hotspot analysis tool to see hotspot trends in the wobbly data. And now we're going to run the optimize hotspot analysis tool. We're going to continue working from the map. Here in the content panel, we're going to hide wobbly January layer, and then the January density as well. So only leave the topographic. And we're going to turn on the wobbly layer. And then on the analysis tab, we're going to scroll or expand the tool to click hotspot analysis and all those tools. And then so optimize hotspot analysis. And then we're going to, in the processing pane, for input feature, we're going to select wobbly. Wobbly, and output, we're going to rename it wobbly, wobbly, and then underscore OHSA, leave other setting. It is the way analysis fail, incident data, aggregation method, we just left as a count incidents within fishnet, and we're going to click run to run the tool, and we're going to hide the robbery layer, and let's just do it now while the tool is running. So the optimized hotspot analysis performed on the optimized hotspot analysis performed on the robbery data is added to the map. The tool, let's close it out and zoom to layer and look closely. Zoom to layer, perfect. And then it says the tool aggregated robbery incidents into weighted features and analyzed their distribution to identify an appropriate scale of analysis. It then determined which areas are significant, including areas are hot, large clusters symbolized in red, and cold, smaller clusters symbolized in blue. Areas that are not significant are symbolized in yellow. So, and then we're going to open this, right click on it, attribute table, and we're going to drag it out. And then I'm going to resize the window. Alright, so we open the robbery OHSA attribute table. Before we look at the value, it's important to make some assumptions and used in statistics. So we are essentially asking the question, is this pattern the result of random spatial process? And how likely it is that this pattern is random. The initial assumption in this cluster analysis is that crime clusters happen in specific areas of the city and are not random. When it is very unlikely that the pattern is random, you reject the null hypothesis, which in this case is complete spatial randomness, and you can feel confident that the patterns you are seeing are evidence of underlying spatial processes. In other words, you have found statistically significant clusters of both high and low values that you can trust, and you can begin to ask questions as to why they occur, thereby rejecting the null hypothesis. The intensity of robbery clustering is determined by the z-score returned in the output. Z-scores are standard deviations and are represented in the table at the attribute named GIZ score fix 3997 standard deviation. As an example, a z-score of 2.5 means that the result is 2.5 standard deviation and is at a high confidence level greater than 95%, typically indicating statistically significant clustering. The probability graph shows confidence levels and standard deviation and probability values that indicates either the significant or randomness of phenomena. So, let's see. Summarize. Oh, no, I don't need to summarize statistics anyway. Then we're going to use the select tool and select. Let's just check it a little bit. There, go back to map and select any of the cells for and let me go to right here. So we use the select tool to select one cell in a red spot, and most likely the z-score of the selected cell is greater than 2.5. However, the p-value is a very low number, close to 0. The p-value represents the probability that the observed spatial pattern was created randomly. A very small p-value means that it is very important that the observed spatial pattern is the result of random process. So this small p-value can be an indication that robbery indicates are not entirely random, and that many contributing factors can lead to their occurrence, such as socioeconomic factors in areas of low-income neighborhood. And now we're going to create a space-time cube to add temporal component to the analysis. Okay. So to do that, we're going to close everything and save real quick. All right. Okay, and then we're going to create a space-time